Thank you. Today is day number 13, 13. And today our agenda is to learn about the services, IP related services. We are going to learn about NAT services, NTP and DHCP DNS. So let's see one by one. Now, when we are talking about NAT, Network Address Translation, why we are using that? So NAT services are something that when you are using that, and I have the diagram as well. So let me quickly go to the diagram where we have the diagram. Here it is. Yeah. So here you can see that you have your internal clients and then you have switched network. And in this switch network, although we have SVI, we have VLAN 2000 and we have VLAN 2001. So 2000 and 2001. Now these internal network switches, if they have to go and use internet or the external resources, then obviously from the core switch, their traffic will go to the core router. So we have two core router 1 and core router 2, and you can think as the edge routers. So the traffic will go and hit to the edge routers, but behind these edge routers, all these IP addresses are nothing but the private IP addresses. And whenever you will go outside, so we have private IP addresses. Whenever you will go outside, you need some sort of public addresses or internet routable addresses. So those addresses can route over the internet. But these are the private addresses. You need to convert to the public addresses, and for the security reason, you will go and use network address translation feature, or you will do network address translation. So one address can be converted to other address. In our case, we want to convert our private addresses to public addresses. Now, there may be chances that you want to do the translation, but you have the use case. So you may have use case that you want to convert many addresses to many public addresses. So many private addresses can be converted to many public addresses, or you want to convert one address to one private address to one public address. So there may be chance that many private address will be get converted to pool of public address, address. There may be one chance. This is nothing but many to many. In function in maths, we have concept like many to many mapping. But still, this private addresses will be like maybe 1000 private addresses may be converted to 10 of the public addresses, 10 of the pool public addresses. Or you may have many to one, like many of the interfaces, they will get converted or translated over the interface. Over the interface means that only one IP address, many of the private addresses will convert over the only one private address. Or what will be the third case? Third case will be that mix of case 1 and 2. So you may have multiple pool of addresses. Few of the pool of addresses you want to do case 1 like many to many. Few of the pool addresses you will go and convert to 1. So suppose I have pool 1 that I want to use case 1. Then I have pool of addresses that I want to use case 2, like over the interface. Over the interface, int to pool of public address. Then again you have suppose pool number 3 that you want to use case 1, like that you have pool of public addresses, you have pool of private addresses. You want to convert either over pool of public addresses, or you want to convert over the single interface. If you are converting over pool of addresses, that will termed as a dynamic NAT. And if you are doing over interface, this is termed as a port address translation. Port address translation, PAT. Even there is one more case that I haven't added here. The case is like this. Use case number 3, that you want to convert only one address to one address. One to one. One to one. This is termed as a static NAT. One to one. One private address to one public address. This is a use case related to servers. We have some servers in a network that we want to convert to only one address, because that server over the different interfaces, they can be accessible via different type of users. So we are doing one to one or a static NAT translation. So now we can see that we have different use cases. Use case number 1, and then you can see that we have use case number 2, and then you can see that we have use case number 3, and all 3 can be mixed, or 1 or 2, 1 or 3, like that they can mix and match. So we have mix of use cases 1 to 3 as per the implementation. Now in understanding this concept, if you have any doubt, please feel free to ask. This is easy, straightforward, right? Let's go back to our agenda. Oops, where we are into the, oh, I'm still in GLPP. Slide number something, 275 or something. Okay. 4.1, 200. That is slide number. That will start with slide number 271. All right. So let me clean this screen here. Clean all. Now you will see the configuration. I'll do the configuration, but here you can see that we have our topology. We'll go to router number 11. I will go and assign this IP address. This is the public address where I want to translate the internal clients. Then I can go use IP NAT source static, one of the IP. This is what, if you are using the keyword static, that means that you are using the one-to-one translation. So one IP will get translated to one IP. Okay, that is static. Then if you want to create a pool of internal IP that you want to convert to the pool of external IP, that is nothing but your dynamic NAT. So you are creating my pool, IP NAT pool, and then you are creating some access list as well, and then you are doing the translation. This is the overload. Overload means the NAT pool plus overload. This is dynamic NAT. This is PAT. Even if I go and use interface, I will show you all these examples. Don't worry about this. I'll configure and I'll explain everything. So this is the dynamic NAT. But if you go and do the configuration over the interface, if you do the translation over the interface, this is also a static NAT. Okay, same thing I can see again and again. I want to see it over the interface. If I go and specify the interface name here, like interface gig00 or something, that will be the PAT. Port address translation. That example I think is not here. Interface name is not here. Maybe it is not there in the agenda, but I will show you that. Maybe it is not there in the list. in the list. Oh yeah, that's why static and pools. But if you go and translate over the interface, that will be the PAT, port address translation. I will go and I will show you all three flavors. So let's do this. Let's do this configuration. So configuration that we want to do. First of all, I want to configure the interface with some public IP address, right? So what's the interface name? E00. I'll come here and interface int E00. You know, the first thing you want to do that this is your external interface. Obviously, you should have some IP address. So let me go and assign the IP address like that. 2030.113.1. 252. Then I have to go to the other ISP router. That interface is E0/1 and IP address is 255.252. No shut. Make sure that we have the reachability to other side. I can see that we have the IP reachability. Now, when you are doing such type of NAT configuration, so this is my external interface. Here I should do IP NAT outside. And over the internal interfaces, so we have some internal interfaces such as E01. So I have interface range E0/1, 2, and 3. And then I have one loopback 0 that also having IP in the range of 10 dot something something. We'll see that. I should do IP NAT inside. So I have IP NAT inside, I have IP NAT outside. Include assign. Oops. Exclude unassign. Yeah. So you can see the IP addresses over the public facing interface, and in the inside interface I have 10.1 network. 10.1 network, 10.1, 10.1. Everywhere I have 10.1. This is my private address and my public facing interface is 203, right? So if I have to do the NAT configuration, first of all, I'll go and create some access list. So IP access list, do the NAT. And IP access list, some standard also will work. We give some name and I can give permit 10.1, 0.0, 0.0.255.25. This is my address. I want to translate this address because everything is starting with 10.1. Then NAT statement. Uh, so in NAT statement, I can show you two type of NAT. One is the port address translation. Even I can show you a static NAT as well. So all three I will show you. First of all, let's start with the easiest one. That is the PAT, port address translation, right? So for that, I can do IP NAT inside source list. What is my access list? Do the NAT. That's the name. And then you can see it is asking about interface. This is nothing for PAT, port address translation. And if you give pool of global address, this is nothing but the if you have pool of IP addresses, that is external IP addresses, that's the public address you can give, right? No problem. First of all, we'll do over the interface. And what interface we have? We have Ethernet 0/0. Then you can see keyword like reload, VRF, and all those things. Overload the address translation. Okay. You have some command that you can go and run. Show IP NAT translations, show IP NAT stats. These are the commands that you can go and run, and you can see the translation. At the moment, no translation. It is not showing any translation because even we are not sending anything. And if you go and check the NAT statement, you will see that we have configured the NAT over the interfaces. Inside interfaces are inside. Outside interface is the egress interface. And then we have the NAT statement, right? So why not let's go somewhere and try to access 203.1.0.113.2. Is the IP we have. And why not? Let's try from here itself. I can try from here itself. And I can show you that you can see the inside interfaces and outside interfaces. So if I ping 203.0.113.2, right? So interface brief include my IP address is .1 and my connected interface is .2. But this, if I ping from source loopback 0, translation, see, this loopback 0, this is part of what? Internal inside NAT, whose IP is this. So it is telling that, yes, you are doing the NAT translation. And if you go and see the stats, you can see here in the stats, active translation, this is using dynamic 1 extended, packet translated 1, like that. This is the list which is working. So, if I go here, just trying to see if it has some reachability for the other side network as well, but you should have some reachability. Show IP NAT translations. And the entry is going immediately because this is dynamic. So if when I'm pinging and then if I am checking, I can see this entry. Protocol is ICMP. Even if I telnet to this address with source interface loopback 0. Obviously, telnet is not enabled actually on that device, but if you go and see NAT translation, I can see this. It is trying, but since this device do not have telnet enable, connection is refused. But you can see my loopback address in this port, try to convert it to this port, and it want to go outside. But here you can see so many different terms like global, inside local, outside global. These are nothing but the terms. So I am coming from where? I am inside local, right? And where it will get converted. What is the gateway I have? Over the router, this is the interface that is connected. This is my internal interface. So that's why this is inside global. Where you want to convert outside local. This is router. This is what? This is a router peer interface IP address where I want to get converted. and this is outside global. So outside local and outside global will be the same in this case, but sometimes it will change if you go and use the global IP addresses. So let me do this. Okay, before going any further, you are able to understand what we are doing here? Making the interfaces NAT inside, outside, and then one line we have used like this. If you have any problem understanding up to this point, please feel free to ask.
In summary, everything from this access list, they will translate to this external IP address, no, from the
100.
outside.
Yeah.
Okay.
From this, you can see matches are there, 3 matches from this list. Yeah, let me quickly check that from switch, how we can go and do this. Show IP interface brief, include assigned, exclude down or exclude unassigned. Okay, so the IP we have over the E03 is this. Let me try to ping from one of the switch. I'm able to reach or not. Okay, so from this switch, I'm able to reach to the inside IP of this router. Then can I ping? Oh, this 203. Okay, so that is not reachable. So I can go to 203. Show run interface E0/0. Okay. Just for my clients, E0/0. IP OSPF1 area 0. So I can reach to this IP from my internal sources. So if I go and ping now, because I convert, because I'm using IP routing, so I'm able to reach this. Now, if I go and try to reach this, is also reachable. Great. Okay, and what about do show IP NAT translations? Was inside 10.1.10.2 IP interface brief exclude unassigned. See, now from inside switch, I am translating that inside network. So behind that router, all the routers now, all the routers, all the switches, all the client, even the clients also, even if I can go here and try to, try to ping or telnet 203.2.0.113. This is the public address. .2 is the public address where we have configured the PAT. If I try to do this, oh, I do not have IP configured, I think. I do not have any IP and gateways configured on this device. No problem. Interface, which interface is connected? E0/0 IP address. 10.2. I don't know what gateway it has. This is connected with VLAN 2000. Okay, and IP default gateway 10.1. I'll give the IP default gateway as VLAN 2000 gateway. Let me first check that it is able to reach to the 2001 or not. Is able to reach. That means it will reach to outside as well. Let me go and check the translation. NAT translations. So no translation. So somehow this host having issues. This is nothing but the network related, reachability related to show ether channel summary. Should have ether channel up and running, and you should have some show IP interface brief VLAN 2000, and those interfaces should be up. So I can see that IP is dot two. If I go and ping 100, this is the VIP IP, right? Okay, it is reachable to dot two as well. Let me try this. Okay, so I can go here, show run section VLAN. These are the thing that we are doing at the moment. It is like, you know, very much like network configurations, interface VLAN 2000. I should do IP OSPF1 area 0. Say it is able to reach to the router inside interface and then outside interface as well. That means if I go here and see the NAT translation, you can see that this is the host, right? Host is now reachable. So if I can show you the diagram we have somewhere in the slide number 249. Now you can see from here I can reach. Up to here anyways I have internal routing, but over this interface we are doing IP NAT inside, IP NAT inside, IP NAT inside, and over this interface IP NAT outside, and then with that able to reach to the ISP. Right? Any doubt so far? Easy, straightforward, right? You can check the video and you can perform the lab as well. Now what I will do, I'll go and quickly configure the other NAT as well. Other NATs are easy. Static NAT and over the pool, like dynamic NAT. The static and the pools. So you have to go and create one pool of address for the public addresses. I can go and create some pool, say like that, IP NAT pool. So let's do that. I'll show the static and the dynamic. We are here. IP NAT. I can see what options we have. Pool and say public address, and then 203.0.113.1 up to 203.0.113 up to 4, and then net masks 255.255.255.2. Suppose this is to 248 slice of the addresses, then IP NAT inside source list. You can see in source we have a static keyword as well. And what is our list of addresses? I don't know. So do show run section IP access list. Source list is do the NAT and then convert over the pool. What's the pool? We have created some public add. It's the name of the pool. And then we can use keyword overload. That is actually over, generally it is over the interfaces and yeah, see the overload, what it will do. Overload and address translation. Obviously it will be overloaded. That means you have very big inside IP, and you have only 4 public addresses. So it will go and do the overload section NAT. Let's see the configuration that we have done now. This is what, this is the first. Now I can see where is that. Yeah, this overload, we are using this overload. Now my first statement is gone over the interface. I can see only this. Apart from that, why not, let's do the static IP NAT inside source static, and for example 10.1.100.10 is client 11 address, and I don't want to do over the interface. Global IP, suppose I want to convert this to 203.0.113.3 to show that section. Oops. Do show run section NAT. Now you can see that we have the overload option as well, and we have the inside a static NAT option as well. So now if I go here and try to reach to any IP outside this also, suppose internet. Now if I go here and to show IP NAT translations, I can see that I have mapping. This is what? This is nothing but a static NAT configuration. Manually, I map this IP with this IP. As it is unreachable, we have mapped this IP with this IP 203.0.113.3. Now you can see success because we have manual entry. So if I go here and see, you can see the statements, right? So that's the thing we have, that's the power we have with the NAT. Internal IPs can be converted to the external IP. And the lab is big. I try to show you all the, yes.
Ratnesh, I have a question. Can you explain again about what happened when you have all your IP address in use from your pool?
It will do overload. It will
And
do the
overload means
overload.
that
Yeah, so one address can be overloaded over 65,000 ports. So when you are doing the NAT earlier, if you see these output, you can see that they are, if we go and use the overload keyword, they will go and use different type of port numbers. So when you are starting with some port number, and it will go and convert it over the one public address, but this public address has the power that it can go and use 65,000 ports as well. So it will go and start overloading those connections over different ports if we will go and use the overload keyword.
Luis, this is commonly used with your home internet.
Yeah.
Nickname of that is, or another name for it is called port address translation.
PAT.
It's yeah, PAT. It's
okay.
very common to be used like at your house because you only get one IP address, so they NAT via port to a single IP address, so that way there's numerous things that go out.
Yeah,
Okay.
use case number 2, you can see port address translation over the interface, many to one. This is use case called many to one. Many addresses we are converting over one interface, but this is not just one IP address. Over that one IP address, you have many port addresses.
Many ports, yeah.
So that's why it is termed as a port address translation, and you can go and use the keyword overload. That means your interface with different type of port number, they are overloaded like that. All right, so let's move to the next topic, 4.2. Let's see what is there. I think that topic is very small, very easy. Let me clean this. This is easy and clean topic we have because You can see here that we have the NTP. This is nothing but the time protocol, network time protocol. Network time protocol means that all the devices in your network should have some sync time, should have the same timing. So in that case, what you can do, you can go and create some NTP master, NTP server. And from that master, these clients can go and get the time sync. Time sync means the correct timing. So if we go and make router 11 as an NTP server, generally it will be some public server where you can go and assign the configuration. Assume that in our infra, router 11 is working as a NTP server, NTP master. So you can go to router number 11 and you can give a configuration like NTP master. We'll see that what is this, some stratum number or something, NTP master, and then the other devices in a network, we will go and tell them, see, NTP master IP is this. In our case, we'll see that what is the loopback address of router number 11, because that loopback address is reachable via all the devices. And then we'll go to the other devices, and other devices will tell, see, the IP of the NTP server is this. Even the switches also, we can go and over the switches will tell switch, the NTP server is router number 11. Then you can go and verify this, show NTP status association like that, and that's it. Again, we have other options, like we can go and create the security keys as well. So you can go and provide the authentication keys as well to the NTP servers and the client. So while they exchange the keys, the NTP information, they can exchange via the key as well. Right. So let's go here and let's see. Suppose router number 11, I can go here and I'll make this what is that, NTP master server. So here we'll make this as a master, and the stratum number, suppose 3, IP interface 3, exclude RnS, and let's see the loopback address is this. Okay. So now I can go to the switch number 101, NTP master, NTP server. All the switches will tell what is the IP of the NTP server, like 11, and so they can go and sync with the router number 11. Show NTP associations, show NTP status. So now all the devices, they should go and sync. You can see stratum 3, sync with this, show NTP associations. You can see it is telling that this is the master where I should go and sync the clock and get the updated timing and all. NTP status. It is unsynchronized. It will take some time and it will get synchronized. But this is the way that we are doing the configuration related to NTP. This is very easy topic, but we should know. First of all, you must have the reachability, the IP reachability, and then you can go and do the configuration related to NTP. Right? NTP in both client server mode. Yeah, we can go and make that client and server mode, and then it should work. So if I can go here and make NTP mode. So you can use authentication key. You can go and use. We are giving who is the master, so obviously it will become the client, and I am not seeing anything related to client mode. I think that is not there. Yeah, you don't have anything like mode client or something. But yeah, that is the actually is easy topic. That's it. Okay, now we have the topic that is little.
Ratnesh, sorry, what is this stratum setting? What is that?
You can sync all the devices in your network with one. If you use NTP, so you can sync all the devices with the same timing, same clock timing. Generally, we
Uh-huh.
are not doing like this. Generally, we are not giving any router IP address to this. Generally, this will be some external IP, some external NTP server IP. We are not giving any router or switch as an NTP server. But in case there is some corner case that you want to make one of your switch or router as a NTP server, then you can do like this.
But the setting stratum, what means stratum?
Oh, you're asking what is this? That is nothing but the timing zones. So I'll tell you that one second. Who is asking now?
Ray.
Hurry, okay. Stratum is nothing. One second. Those are different type of zones. One second. Just a second. I'll show that. And then, anyways, next topic is very big and it will take some more time. So I'll not go there. We'll discuss all these things that whatever we have studied. Okay, let me pull some link here. One of the link I like. I'm trying to pull here that. You can see my screen, right?
Yes, we can see it.
This is the accuracy of the time zone. What exactly it will define? Let me try to pull one. That I like that link. That is where it's gone. IP. What is that guy? He's writing very nice blogs. Cisco. If I type Cisco, 100% it will come. Network lessons. Yeah, network lessons. I like this. But they have some paid services, these guys. But they are explaining everything nicely. Like, you will give some public IP associations. I hope he has explained the meaning. The stratum is nothing but the time zone we have in the hierarchical order. So when you are getting the time, that will tell you the exact match or the accuracy related to time. And you have this stratum divided from 0 to 15 like that, and then you are assigning. So they have not explained this, but I will get some notes exactly what exactly is this, and I'll explain in the next session what exactly it is doing. This is some maths calculation. Something is like this. You can see that the stratum 1 is a server more accurate than a stratum 2 server, and like this. Some public server reference we have as per the time accuracy or something. But I will create some notes about this, and I'll show in the next session.
Okay, thank you.
Apart from that, do you have any other query? Okay, so next topic we have about the DHCP and the DNS. Now DHCP, we need to go and learn, understand this, and we have to perform a lab task as well. This is dynamic host configuration protocol that automatically the end host systems will get the IP addresses from the DHCP server, and DNS is it's like IP to name a resolution protocol, domain name systems. Now, why we are studying these things? These are the services. These are the services. They are installed in some Windows server or Linux servers, etc. But these are the services actually that you can go and enable in your routers and switches as well. But if you go and enable these in your router and switches, then and these are the services, remember. Then suppose if that router or switch will go down, that will impact the entire network. So generally what we are doing that these services, these services like DHCP, DNS, these we are installing to some outside server, and that server we have some high availability like failover and all those things configured to that server. So in that cluster of servers where you are having these type of services like DHCP, DNS, if anything will happen, with those one server, if one server will go down, still you have DHCP, DNS services running, right? So these are the configuration that generally we are doing. Generally, we are not doing actually over the routers and switches, but you can go and enable these services. And in our course, we have to enable these services over the routers and switches, and then we have to work on that. Okay. So I can go and do the configuration like you have some server you can go to router and you can enable the DHCP services, and then how they are releasing the IP addresses. You have to go and configure some services like what is the pool address, what is the gateway, what are the other attributes of DHCP, and that router will become the DHCP server, and that router will go and provide the IP addresses to the other members in the network. So what I'm telling here is this, that you can go and make one router or switch as a DHCP server, and then you have the network. So in the network you may have switches connected in the network, and in this network these switches, suppose they are connected with some PCs, suppose these green colors are nothing but the PCs. So these PCs that connected with the switch, these PCs will get the IP addresses from the DHCP server automatically, and here we'll go and make this router as DHCP server. Suppose R11 is my DHCP server. So I can go to router number 11 and I can create some IP address pool. Suppose DHCP pool, and then the default network I have to go and give some network and some other configuration. Then what will happen? That it will get the IP addresses, but over these interfaces, you have to go and do the configuration IP DHCP client. IP DHCP client, if it is a router, obviously in the Windows system, you have to go to the NIC card and you have to enable option like IP DHCP. So in the NIC card, they will try to get the IP from the server, and they have some process is called DORA, DORA, like, discover packet, then server will offer something, then server will release that IP, and I think it's got assigned to the interface. Discover, offer, release, and assign. These are the process by which they are getting the IP addresses. Right, so I created some small technical slides as well, that what is the IP assignment, network configuration, lease management, all those things are there, how we can go and create this, and then the devices will get the IP, and then the DNS. DNS is IP to name resolution, that when you are surfing internet, you are typing what? Google.com, but behind the scene, it got converted to some IP. Like, for example, Google.com will get converted to 4.4.4.4. So these type of configuration you can do over the routers, over the switches as well. You can go to router, you can make this IP DNS server, you can go and create the domain name, and you can map the Google IP with Google URL with this IP, Yahoo URL with this IP. So URL mapped with the IP, URL mapped with the IP. Generally, we are not doing this with the routers and switches. It is recommended that these services you will run over the servers, not over the routers or switches. But you have option, you can do it, right? We'll do the configuration in the next class. In the next session, we'll do the configuration and we will continue from here. So far, if you have any doubt, please feel free to ask. Next class, we'll do DHCP and DNS and SNMP. Recording. Thanks for joining. Day number 14, we are continuing our learning related to IP services and management related services. You can see that now we have topic related to DHCP, DNS, and then today we are going to learn about SNMP as well. Simple Network Management Protocol, SNMP. What's the use of SNMP? How it is working behind the scene? All those very important aspects related to SNMP we'll go and learn today. But let's start with DHCP and DNS. DHCP is nothing but Dynamic Host Configuration Protocol. You can see in this topology, I can go and create this router 11 as a DHCP server. So that means all the hosts, you can see here, all the machines that we have at different places, they can go and get the IP from the DHCP server, right? So that's the use of DHCP server, that generally what we are doing, that we have some DHCP server, some server where we are creating DHCP services, DNS services, even SNMP services, NTP services, domain services, AD related services that will be in some Linux or Windows server. And then from there it is working. But we have option that we can go and create DHCP servers over any of the Cisco router and switches as well. Not only DHCP, but we can go and create some private DNS server as well. We'll see that, how we can do. Let's just start with the DHCP, and then we will check that DNS as well. Where is my server? Oops. Let me get my okay, I have server, and will go and enable the services. We'll see that over router number 11. But in terms of theory, how it is happening, that assume that you have DHCP server somewhere, and then you have the clients. Client 1. Because if you have server somewhere, then you will assume that you have clients somewhere. Then we have the client server relationship. In this server, we have DHCP services enabled. Now, what is happening that obviously these clients need IP address. So there is one process called DORA. Discover, offer, request, acknowledgement. Offer, discover. This process is happening. And with this process, what will happen that these devices, they will request, and then server will offer, then they will request that I need this IP, and then server will acknowledge, okay, stick with this IP. Like that, the relationship will happen. Now, while creating the DHCP services over the router or Cisco switch, you can go and have multiple options. So what options we have, let's try to see here. First of all, you can go and exclude some addresses. Those addresses you don't want to assign, right? So suppose if I don't want to assign some address, for example, I don't want to assign 10.1.100.1. Why? Because this is my HSRP VIP IP, virtual IP. I don't want to assign 101.1 because this is my virtual IP. Then I don't want to assign .2, .3 because these are my gateway addresses. These are my switch gateway addresses. So you can see that plenty of addresses I don't want to assign. That's why we are using IP DHCP exclude addresses. I simply want to exclude this. I don't want to assign these addresses. Then what you will do, you will create one pool. You can give any name. So I have one IP DHCP pool. Pool name is for clients. And here, whatever IP that you want to assign. So suppose I want to assign 10.1.100.0. Even you can give like this also. Or you can go and give the subnet mask like to it. Both is okay. Both you can see. Either CIDR notation or subnet notation, both you can give. Then you will see if I go and type question mark here, we are within the DHCP config within the pool. I can see in the DHCP config, what are the things you can go and do? So you can go and give the lease time, some net BIOS. These are the old system related to DNS mapping. You can go and advertise the network. You can go and give some ODAP. Even I don't know what is this ODAP. Some DHCP options. Yes, you can go and give some DHCP options. The DHCP options we are using in case we are working in the DNA. In DNA, we are enabling one DHCP option 43. So within the DHCP request, it should understand what is the DNS IP that will be coded within that option 43, and then clients are receiving that option. Then you can see the relay. I am going to explain you relay because we have separate topic related to DHCP relay today. Then you can go and give the renew time. So many things you can give. You can give the lease time as well, that how long the DHCP request will get released and new request will come into the picture. So lease, you can see that 0 days, 365 days, up to 365 days, infinite, like for infinite time, that IP will get stick to that particular device. Suppose lease is 24 hours, then you can see the other things. So network we have done, we have given the lease, then you can see that relay will check later on. Server, some server option, update utilization over the VRF we can go and give. Import, you can import DHCP options, hardware. So many things are there, but you can go and give the domain name, say www.cisco.com is my domain. DNS server, do you know what is your DNS server? Say www.cisco.dns.com. DNS server IP, host name or server name. Okay. ABCD Cisco DNS. Why it is not taking like this? Server's name ABC. It's not taking. Okay, no problem. 10.1.100.254. Okay. Section DHCP. Let's see that what are the things we configured. So in our DHCP pool, we have the network. We have the network means that from this network, I want to assign the IP addresses, but I am excluding .1, .2, .3. Then we have the domain name, then we have the DNS server. Very important thing that we should give the default router. What is the default gateway where those clients can go and request about these IPs? So my router, let me quickly see that if my router is my default gateway, exclude unassigned. So I can go and give this IP as my default router. Now you'll see. Now you can see this is the full configuration. How it will get utilized, I'll show that. Before doing this, let's go back to the theory and let's see. So now what you can do with DHCP, that you can do the IP address assignment. You can do the network configuration where you can give the default gateway, DNS, subnet mask. You can go and give the lease management that IP will get renewed after 1 day, 2 day, 3 day. And then you can go and create pool, subnet, default, DNS. Even you can exclude the addresses like this, either one address or a range of addresses. Then if certain interface, so suppose in our diagram, if this is my DHCP server and I want to assign the IP address to this particular switch over this particular interface, right? So I can go and do that. I should go to this particular interface and I should use one command, IP address DHCP. We'll see that. I'll show you that. So then you can go and do that. Then we have the DNS. Okay, so let's complete this. I'll show you the assignment. Not we will assign the addresses to this interface, but our goal is to assign the IPs to these hosts, these PCs, which is far behind the scene. I will show you both the options. So first of all, I'll release one IP for this interface, and later on I will release the IP to these hosts. Let's see that. First, to be sure, run interface E0/. This is the interface which is connected. 10.1, 10.1, okay, and over to show run interface E0/. 0. So here you can see that this is the IP which is this is the configuration. I should take the configuration backup, and I should okay, anyways, this is the backup we have. This configuration I need at least this much. So remember this IP .2. Oh, this is a point-to-point link, no problem. So what I will do here, I'll go here to interface E0/0, and I can do IP address DHCP. Now before doing this, let's do one thing. Let's just start the debugging. Debug IP DHCP server binding class events packets, so I can show you those things. And snooping, I have enabled the snooping. Later we will see that. Okay. Oh, DHCP packets are already going. Interface E0/0 IP address DHCP. OSPF, no IP address, no IP address, something. Neighbor is down. Checking the lease. IP address changes on the interface. Okay. Do show IP interface brief E0/0. Now you can see that IP address is unassigned, but now the method to assign the IP address is via the DHCP. And E0/0, you can see the config. It is trying actually, it is trying to get the IP, but it has some issue that we can see here that is unable to get the IP. Why? Boot request, VLAN ID out of class. It is not getting the IP on this interface. Why? Because if you see the configuration that we have, let me go back here. You should run section DHCP. Let's see the DHCP configure. The gateways and all those configurations are wrong actually. This gateway is for VLAN 2001. So let me do one thing. Let me go back here and let me go and revert the configuration. E0/0 IP address 10.1.10.2 IP OSPF area, IP OSPF 1, area 0. Now they are formed. What I can do here, I can VLAN 2001 or maybe 2000. If you see VLAN 2000, oops, VLAN 2000, if you see that configuration, you will see that over VLAN 2000, we have some IP address like this. Because the gateway address that we are giving is what? The gateway address is 10.100. This is a specific to VLAN 2000 in our infra. So I can go to VLAN 2000 and then I can do IP DHCP, IP address DHCP. And do show IP interface brief for VLAN 2000. Now this VLAN 2000 should get the IP. And here I will do one more change. Okay, let's wait here. Some snooping is expiring. Let's wait. We are getting some error messages because I will explain you why we have this error message after some time. But yeah, you can see it is unable to assign the addresses. One very important aspect about these DHCP services that they are, so when you assign the DHCP services, then you can see this diagram here. When this request and offer is happening, this is assumed. So DHCP discover message is assumed within same broadcast domain. That means that if your DHCP server is in one network and your host PCs, your laptops where you want to get the IP, if it is in some other network, then this message will get dropped at the gateway level. So in that case, what you need to do, you have to go and configure some sort of relay agent. You have to, there is one configuration called IP helper addresses. Then only those packet will be within the network, and then it will broadcast it to other network. If we do not use IP helper address, it will not work. So here you can see the error message behind the scene. Since we have given the gateway, so if you see the gateway here, gateway is our network gateway is, so our network is this 10.100.0. This is different network, and the default network that I am giving is some loopback like 10.1.255.11. So these two addresses are not in the same, right? Not in the same network. So that's why it has some issue broadcasting the configuration or broadcasting the DORA, broadcasting the discover packet. So what we can do here, let me quickly go here and change the gateway. So default router is 10.1.100. What's the, do I have default configure in my router? Let me see. So if I go here and check to show IP interface, brief include or exclude unassigned. So I don't have that 10.1. In my network, I don't have that 10.1.100.1. This is only there over these VLAN interfaces. Right? And that's the reason they are not getting the address in this range. So what I will do quickly, just to make you things, you can understand these things, I will do one thing, quick thing here, just to show you that how they are releasing the IP, and then we'll change the configuration. So we are here over the interface E0/0 IP DHCP IP address DHCP, or I can do one thing, default the interface. Let me default the configuration for this. I can go to E00 and IP address DHCP, no switch port, IP address DHCP. So it will get IP from DHCP, right? Now I'll go here and section, you see the IP configuration, that for the pool configuration, I'll go to this particular pool and network, I will advertise my network, that 10.0 network, and then the default router 10.1.10. Do I have 10.1? Yeah, so that one. And now you will see brief exclude unassigned, that they will go and get the IP via DHCP. So 10.1, 10.2, IP that it is getting. How it is getting? How this interface is getting that IP? This interface is getting IP via the DHCP server. Now if we go to DHCP server, and if you do to show IP DHCP binding, you can see that your DHCP server has released the IP, but this is in the same network IP, right? With this. This is the way that DHCP is working. But this example is what? This example is simply within the network, right? This example is something that you can release the IP within the same network. So here I have the server, and here maybe I have switch, and with this switch I have connected PCs, and for all these PCs, who is the gateway? If gateway is defined to this router, then the router will release the IP. But in our case, the story is different. In our case, it's actually very different. In our case, we have the DHCP server, and then this DHCP server is in network 10.1. some 10.x network. Then I have my VLANs here, and these VLANs that we have, they are in the network 10.1.100.0, right? So in that case, what you need to do, I'll come to this DNS and all those things. In this curriculum, if you go to subsection 4.4, there is one not 4.6. There is one concept called relay.
Right, yeah.
DHCP clients and relay. So what we need to do that I don't have diagram here, but you have to go. You can create DHCP server, no problem, like this, right? DNS domain, all those XYZ. You can do the excluding and all those things. You can go to router and enable DHCP. But now you have to go to the VLANs. You have to go to the VLANs, and over the VLAN you have to do some IP DHCP helper address. That's the concept we have with the relay. Then only it will go and relay the addresses within the other broadcast domain. If you have different broadcast domain, that means different network, you want to take those IPs, you need to do the IP helper address configuration that I'm going to show you now. Let me go back to the diagram. Here it is. So what I'm telling that this is in different network and this is in different network. So you have to go to the network where you have the gateway defined, right? And there you have to configure the IP DHCP relay agent. So let me show you, then you will understand more on this concept. So far what I have done, I have shown you that, okay, within the same gateway network, you can get the DHCP addresses. No problem. It's easy peasy. But I'll go and revert the configuration. I don't want this actually. I want network 10.1. Even I don't want this name, say for VLAN 2000 clients. I'll create two DHCP pool, one for 2000, one for 2001. And then what is the network here? We know that our HSRP gateway is 10.1.100.1. Oops. And then what is the default for this? We know that HSRP gateway default is this. Then I'll go and create one other pool for 2001, where we have the network is this, and where we have the default like this. Then I must have IP, let me go out from this, IP DHCP exclude address 10.1.100.1, 100. Suppose up to 9 I want to exclude. I want that PC should get IP from 100.10. So I'm excluding
Okay.
.1 to .9, .1 to . So these are the addresses. Now I should go back here to my switch 101 interface E0/0 IP address 10.1.10.2. I'm reverting back the configuration. So IP OSPF1 area 0. Now you will see here, I should get the OSPF processes and all. Now if you go here to host number 11, and we know that this is connected with E0/0 IP address DHCP. So you show interface brief E0/0 to show IP int brief E0/0. Method is what? DHCP unassigned. It is not getting the IP. It will not get. Why? Because you have to go to the switches, say VLAN 2000, and you have to make one more configuration, that is IP helper address 10.1. What's that IP of your router? This router loopback interface is 10.1.255.11. So you should go and give this IP helper address in this VLAN, and then I should go to VLAN this and assign this. Now you will see that they will broadcast, and let me go here and make sure that it is pinging the gateway. Who is the gateway? 10.1.100.1, right? So here I'll go an IP, assuming that this is some Windows PC or Linux system, and if we ping to another host address or protocol is not working, no problem. No IP routing if I do. Okay, do show run interface E0/0. Okay, IP address DHCP 0/0. Now shut, and we should check the interface here. Do show run interface E0/0. It should configure at switch port mode access, switch port access VLAN, and to interface E0/0. No shut, should be up and running. And let me check from here. 10.1.100.1 should ping. Why we are getting this issue? We don't have VLAN 2000. What about the SVI? Shut. We should ping from here. Otherwise, how it will get the IP? Why it is not pinging the gateway? Exclude unassign. Let's see. Something is down. Don't have any IP address. So let me do one thing. I'll create some dummy IP here. Say 8. And okay, let me ping now. Okay, now. So from this switch, you know, this is access switch. I'm able to reach to the HSRP gateway. These IPs are nothing but the HSRP gateway's IP, right? And now let me quickly check that from the host, I'm able to ping to the HSRP gateway. So host is unable to ping. Because it is unable to ping, so obviously it will not get anything, right? It will not get any information. So how we can make this up, right? To get the IP. Okay. Okay, let me try one more time. IP routing. Gateway we have defined, right? This is the gateway. And I'll do one thing. That's the time being this. Just to make sure that I have reachability. I'll assign some static IP. Let me try to check. Okay, now it is reachable. IP address DHCP. Wow. Strange. Strange. No problem. We'll try to fix this issue. You can see that issue is there. DHCP binding. But where it is getting this IP? 10.100.101.10. Oh, so so IP interface brief. Sorry. Sure, and interface E00. Someone is getting this IP. You see, but you can do this thing: clear IP DHCP binding star, just to flush the database. And now the IPs are clean. And let's go back here. Let me quickly see the configuration for VLAN 2000. Oh my God, what I have done here. See, that's why it's not releasing the IP. Let me undebug all. Earlier, what I have done, you may remember that I have given this type of IP address DHCP, and these interfaces are actually getting IP from the DHCP server now. But we should go and remove that. IP address for this gateway, for this VLAN is some static IP like 100.2. And likewise, for VLAN 1, the IP address is this. Now let's see. 2000 and 2001. Now it is correct, right?
Yep.
I can see correct. And we have two different helper addresses configured as well. But anyways, one is down. One DHCP server is down. So it will go and check the other DHCP server. And I should go here and first of all, let me see. So now you can see it has released actually the IP addresses. Let me go and clear this. Once I go and clear these, right? You can see no IP is there. No IP is there, which is good. Now, if you go and see, now they are assigning 11 and 12 to these MAC addresses. Wow. 11 and 12 assigned. Show IP into brief. 0/0. Where it is releasing the IP? Because I have removed that configuration. Show run interface. where it is releasing the IP. You can see again, instantly it has released the next available IP. So 10, after that 11 and 12. Earlier, what was that IP? 10 and 11. Now next IP it has released. Let me go and clear this one more time. Because now we have done the static IP binding. Static IP binding. Okay, a static binding. So now it is not, or now it is releasing this IP 10, 100. Okay, let's quickly see here. Interface VLAN 2000, 100.3, 101.3. Helper address is let me remove this. What is our helper address? Our helper address is, what is that IP? Our helper address IP is the loopback address. Show run interface loop 0. This is our helper address, right? 255 this. No problem. I can go and give our helper address, and then I can go to VLAN 0. Our helper address is this. Likewise, I can go here to this particular switch interface. Oops, this particular switch interface VLAN 2000, and I obviously we have this configuration, but I don't want this. Some conflict there in my configuration. Do show run interface VLAN 2000. Let's see. Now I have the correct helper address assigned, and interface VLAN 2001 also. I'll go and remove this, and I'll go and assign this VLAN 2001. My God, it's too much troubleshooting we are doing. Okay, so configurations and everything is correct. Now let me go and check this access switch. And let's see, do show run interface VLAN 2000. We have some IP here, 2001. We have some IPs here. Now let's go back here and check. Now it is releasing some IP, this and this. 12 and 13. But it is not getting any IP. It's very strange. 10.1.100.1 unrecognized host or address protocol. It's not our problem, but still I will try to, I want to fix this. So far, before going further, so far let me go back here. Let's see. You are able to understand everything. We are creating DHCP pool for VLAN 2000 and VLAN 2001. And since this is in different network and the VLANs are in different network, so what I am doing, that I am going to the VLANs and I am configuring the relay agent IP DHCP helper address, IP helper address, and I am pointing the helper address, the DHCP server address. So it will take this IP and it will reach here, right? Understanding up to this point, if you have any doubt, please feel free to ask.
Oh, no, I think I'm good. Yeah, I get the this the relay, yeah, the relay information is.
So we are doing everything right, but somehow this PC is not getting the IP. So we should go and check this interface. This interface, something is showing that protocol is down, right? And that's why we are not getting the IP. But it's a strange that someone in the network is getting IP. Constantly, they are getting some IP, like 12 and 13.
And question, the first IP assigned, it should be the number 10 or 11? Why starting with 12 there?
Oh, 12th. We have excluded some addresses. So if you see the configuration, so
Yeah,
what
but you
happened?
exclude 0 to 10
0
or
to
0 to
9.
9?
We have
0 to 9, yeah.
excluded 0 to 9. But what happened that earlier it has released 10 and then 11. So whenever I am clearing the database, this is the database, clear IP DHCP binding, and then it is releasing the next IP in the line. So now it will go and release 13. You can see 13. Earlier it was
Yeah.
releasing 12. Now if again I clear, it will offer next IP. Like that it is offering the next IP in the line. Okay. But where this IP is going? It should go and reach to this interface. But since it is showing that I am unreachable, it is not getting the IP. E0/. Let's see, something is do show interface E0/. Should be up because we have checked that we assign some manual IP and then maybe some DHCP snooping is configured, which is blocking IP DHCP snooping over the switch 110. Let's see. I should not do some security configuration in this. Show IP DHCP snooping. Port channel. Aligning over the port channel 1 and 2. Trusted. Yeah, some DHCP snooping configuration is there. So that's why seems sure section DHCP. We have that topic later on in our CCNA classes, that DHCP snooping. IP DHCP IP helper we have done, right? So what is that IP DHCP relay? Let me check that what I can do to protect from DHCP, or I will go and remove the configuration. We are inside the config and I just wanted to remove or add some DHCP configuration. Actually, it should come here over the VLAN. Let me go here. Interface VLAN 2000 IP DHCP relay information trust. It should be there. And show IP interfaces. And then I'll do one thing, that clear the database. Release and renew. We are sending the new broadcast packet, DHCP packets to the host. Now it is getting the new IP in line, but that is on other VLAN. So interface VLAN 2001 also, I'll go and make this. And not only this side, but this side also, interface VLAN 2000. Yes, because snooping I have configured, but we haven't covered this part. Later on in the security section, we'll check that. What is the use of snooping? Clear the database. This configuration is little bit complicated now. So I'm releasing and checking that these hosts should get some IP. 10.1.100.1. This is the VIP gateway. But protocol is not running. Okay. IP DHCP. These things you don't need to do. Whatever I'm doing now, I'm just troubleshooting. IP, DHCP. Even I don't need to do any all those things, whatever I'm doing here. Simply I need to go to interface E00 and I have to configure this IP address DHCP. That's it. And it should take the IP from the DHCP
The address.
server. You don't have to do any other thing in the host side, from the host side. Even I don't have to go and configure the default or something. I have configured this 10.10.100.1. I don't need this. No default, no IP default gateway. So let me remove this. You don't need anything. You just do this thing and you should get the IP from the DHCP servers. Yeah, but one thing you can do for sure, you can go to this interface. You can do shut no shut. Shut no shut means it will try to start the process, the Dura process. Like your interface is down, then it is coming up. When it will come up, it will see, oh, I don't have IP in my interface. Shall I send the packet to the devices? So this shut no shut may work. And let's go back here to this. I'll see. It is releasing IP, but who is getting the IP in the network? I don't know. I'll go and remove this security configuration, the root guard and all those things.
You're being hacked. Someone else is trying to connect.
I don't know how it is releasing IP, but I can't see any IP over the interface. You can see unassigned. And yeah, issue is this, that I'm unable to reach to my gateway. Unrecognized host or address or protocol is not running. So it's not able to ping to the gateway. Then how it will get the, means this protocol down error is something different. Okay, we'll do the troubleshooting for next 5 minutes and we will stop here. I'll try to fix this issue. Means everything configuration is correct, the relay agent is correct, everything is correct only. Some issue I can see here. See, configuration is right. So if we go bottom to up, so these hosts are connected with this switch. If you go to this switch, 00 and 01. And if you go and check the physical interface, so show interface E0/0, it should not be, this is up, see, this is up and this is also connected and up. They are layer 2 interfaces. Then even if I can go and check, show IP interface brief. So this switch, we have assigned some addresses, these VLAN addresses. Even I think these VLAN IP addresses are not required. You need some management IP here, some management IP. So this switch can understand something. You don't need this IPs over the interfaces. Some management IP I need. So it can understand the protocol. I'll do one thing. To E0/1 IP address. Wow. I have given some dummy address. So at least it will show me that protocol is up or down. Right. So now at least my ping packet is going through. I have given some dummy IP here. But this is the interface I am expecting the DHCP addresses. So now I'll do one thing. I'll do shut and no shut. So it should send some packet. It will go to switch 110. From there it will go to 101. From there it will go to the server, DHCP server, and from there it will get the request to 101 within the VLAN 2000, and then it will forward it to the switch, because below this switch 101 everything is layer 2. So we don't need any helper address or all such configuration, and then it should get the IP and it should work. Right. So do show IP interface brief. It should get some IP here. It should get assigned some IP that I'm not getting. Anyways, no problem. I'll come back here. Binding style. Let me clear this. Some IPs someone is getting. Let me mute you guys because I'm recording this session, and this is a good session because we are doing some troubleshooting. And we are doing some troubleshooting here, real-time troubleshooting, that everything is correct in a network, but is still I'm not assigned the IP address. This is a little bit complicated example because we are taking that broadcast packet and sending to the downstream switches. Okay. So if I go here, let me show you something. IP address DHCP 2000 shut show IP interface. Just checking that this request I am getting to my switch number 101.110 or not. I can see I have assigned as a DHCP because if it will not come to this switch, it will not go to the host machine. And sure, I know that what is the issue, but I just wanted to show you that how you can go and check that. Take some time to release the IPs. '17. My DHCP server is good. It is releasing the IP, but it is not coming here. You can see it is not getting any IP. And if I go here, brief. IP interface brief. Yeah. Okay, so what I will do here, that we have too many security configurations by default in these switches. I need to go and remove those configurations, those security configurations. So let's go here and do one thing. If I remove that, let's see. Show ether channel summary. I have this LACPs configured, right? And show run. Let me show you that. DHCP. So I have this DHCP. Where is the IP DHCP address? So snooping configured. So I'll do config no IP DHCP snooping. Why? Okay. Remove this section DHCP. IP DHCP snooping trust to show run interface port channel 1. I know that where it is configured over the interface is another port channel 1. No IP DHCP snooping trust because I'm not running this snooping. And over to this may block my DHCP packets that is coming from the devices to share section
And question: the snooping is a
We,
security measure, or what is that?
we have this topic in CCNA security.
Okay.
We'll check that. Okay, great, good. So I have removed those snooping and show IP int brief interface VLAN 2000 shut, no shut. Show that interface to show interface brief. Let me assign IP here and then we can go and check the switches. First of all, we should get IP here. I'm just checking part by part. So why it is not getting IP? Too many transmissions, no problem. But it is releasing the IP. You can see releasing the IP, but I'm not seeing any IP in my interface. I should see IP here. Sure, and do show interface VLAN 2000. Protocol is up. Negotiating DHCP. Okay, good. Okay. And my router also releasing the IP. Okay, so clear IP. Let's clear this table and let's see the binding 19. This hardware address. Okay, and my switch 110. Okay. Okay, so it's actually easy configuration. I told you that I know that what is the issue. I have so many security configurations. Run interface VLAN 2000. Let's see. So I'm using some burnt in address concept as well. And again, what is this burnt in address? Is he expecting that I should go and this little bit advanced, but yeah, is expecting that I should go and do some manual IP to MAC address assignment over the DHCP server. So if I am here in the DHCP server, section DHCP, let me show you that because removing is not a good option. So if I am here, I think IP DHCP, I have to go and assign some IP to MAC binding. So there is one option that you can go and glue the IP address with the MAC address, right? Some hardware addresses and all those things like give and then, like that you have to do. So some manual assignment it is expecting to do us, but let's do one thing. Let's go here. I'm over this interface, right? And no, I will remove this just for the time being. 2001. Let's remove this and go here and clear the database. Okay, and Whenever I'm getting this, I'm getting. Okay, let's go here and see something should happen. Interface VLAN 2000 shut. No shut. Should get some IP. I think now I have removed everything. Everything means all the security configurations and all. Now it should work. It is releasing some IP as well. Otherwise, the next step will be that I will go and manually glue these IPs, these MAC addresses to these IPs.
Yeah.
Yep. You're asking something?
No.
Because you can see that after doing this also, the host, they are not getting the IPs unassigned. But my server is very good. It is releasing, telling that yeah, receiving or not. From my side, I am releasing the IP addresses. You should go and have these IPs. And all the time, it is assigning new IP addresses.
Yep.
Okay, so what I will do that the configuration, everything is same. There is no problem in that. I will go and remove some security configurations. All the devices have some security features enabled. I'll remove that and I'll show you that how they will go and get the IP, because we are running just out of time. So we can stop here. But don't mind, the same configuration I'll continue tomorrow, and then we'll start the Python